Okay, more trig. So you want to have your good buddy formula sheet out because you want to, I want to be talking about where it is as we're doing these. You mean another one? They're up top there. I don't think. Here, we'll just pause. The people at home don't need to listen to this. Okay, so these are all on your formula sheet. These are the sum and difference, right? So if you can find those on your, they're called the addition subtraction instead of sum difference. So of course, you don't have to memorize them this year. You'll probably have to memorize them next year. So that's what really ups, I guess, the difficulty in calculus in university is the no formula sheet. Okay? So just to know where they are in your formula sheet, and then we'll talk about how to use them. But again, you do not have to memorize them. Now, we're just going to talk about odd even functions. We've done this already. Now, if something is an even function, it means it is a reflection on the y-axis. If it is an odd function, that means that if you did a 180-degree rotation, it would give you the graph on the other side of the x-axis, or y-axis. So you can see this one here, okay, and I don't know if this will even let me rotate it here, but, oops, definitely not letting me. Okay, so if you rotated it, you could see that it is an odd function. So this one's odd. That means that sine negative theta is the same thing as negative sine theta. And you could even verify that with your unit circle. Okay, so this one would be odd. Now you could see cosine, you don't need too much of an imagination to see that is a reflection on the y-axis, right? And that's when you take x and replace it with negative x. So cos negative theta equals cos theta. So this is even. Okay, tangent. Do you guys have a tangent graph? No. Okay, so that one's pretty easy to draw. It just looks like this. Okay, so that would be odd as well. So tan negative theta equals negative tan theta. And these are all on the negative angle identities right there. Okay, so again, you don't have to memorize them, but I think it's good to see why they are, because we do even and odd functions in the last unit, and it just carries on the same thinking. Okay, so let's just do some 30-1 review, or for some of you, we haven't done these yet, so this will be new, but it's not a difficult concept. This is just how do you find the exact value of sine 75? Okay, so 75 is not on your unit circle. So you've got to find a combination of two numbers, either if you subtract them or if you add them, give you the answer 75, and those two numbers are on your unit circle. So what are 2 degrees that we know on the unit circle that would add to 75? 45 and 30, right? So if you look at your formula, let's use the sine A plus B. Now you got to steer C or sine A cos B plus sine A sine B, right? It's the very first one on your addition, subtraction, identities. So sine 75 degrees is the same thing as sine 30 degrees plus 45 degrees. And if you want, you can call that A and that B. And all you're going to do in the formula is wherever you see an A, put in 30, wherever you see a B, put in 45, and then we'll be able to find the exact value. Okay? So this would equal sine A, which is 30 degrees, cos B, which is 45 degrees, plus cos 30, or A, which is 30 degrees, sine B, which is 45 degrees. Okay, so I've got this one and this one going. So this is root 3 over 2 comma 1/2, and this is root 2 over 2, root 2 over 2. Okay, so this is where I'm going to get all my information from. And remember, this is cos and this is sine. So sine 30 is 1/2 times cos 45 is root 2 over 2 plus cos 30, root 3 over 2, and sine 45 is root 2 over 2. Okay, you just multiply the two together, you get root 2 over 4 plus, that would be root 6 over 4. So your final answer would be root 2 plus root 6 all over 4. They have a common denominator, so you can just add the numerators together and put it over 4. And you can't simplify root 2, you can't simplify root 6, and you cannot add that to be root 8. Okay, when you add or subtract radicals, they have to be identical underneath the index to be able to be added together. Okay, so if we go back the other way, because we don't know how to find sine 50 or cos 80 or cos 50, so we can use a sum or difference. And a sum, 50 plus 80, still not a gooder, right? Unless you know your 130. I don't. So what should we be doing? Okay, so go cos or sine, because if you look at this one, this is the sine. You could do a plus b, or we're going to do a minus b. So we're going to go 50 minus 80. Now that is the same thing as sine negative 30 degrees, and like we just learned, that's the same thing as negative sine 30 degrees. Okay, so in final answers should always have positive degrees, okay? So we'll just kind of, that'll be the rule. So if you're leaving it as sine negative 30, we can say, well, that's not quite done. Okay, so if we are in the interval pi over 2 pi, okay, and that's where x is. So x is in quadrant 2, and it says y is in quadrant 3. And it says cos x equals negative 5 over 13, tan y is 4/3. So it wants us to find out what is cos x minus y. Well, let's just write down the formula. Cos x minus y equals cos x cos y minus sine x sine y. Okay, so we need to find cos x. We already have that one. We need to find cos y. We don't have that one. Sine x we don't have, and sine y we don't have. Okay, so right now this formula is not too good for us. But we can use the information from this, because we can put, I'm just going to get this out of here, we can build a triangle here, and we could say that cos is x over r, right? So that would be negative 5, and that would be 13. So we need to find this side here. and that we would use good old Pythagoras, right? So if we go 13 squared minus negative 5 squared, take the square root of that. Now it's going to be a plus minus, and it works out to be plus or minus 12. So which one would it be, plus or minus? Plus 12. So this is a plus 12 right here because we're in quadrant 2 where y is positive. Okay, so tan is 4 over, so that is y over x. So 4 and 3. Now right away when you put it in that quadrant, you should realize that those are not supposed to be positives. They would both be negatives, which gives you a positive 4/3 when you divide them because the negatives cancel. But when you put them in there, make sure you're, okay, and so we need to find the hypotenuse now, right? So let's go negative 4 squared plus negative 3 squared. We'll take the square root. That's plus or minus, and we get the answer plus or minus 5. So which one would it be? Plus 5, because radius is always positive. Okay, the rest is easy. Okay, cos x. I already gave it to us. That's negative 5 over 13. Cos y is negative 3 over 5. So I guess I'm gonna put an x here and a y here so we keep those straight. Okay, minus sine x. Sine is y over r. 12 over 13. Sine y is negative 4 over 5. Okay, multiply this together. 15 over 65 minus 48 over 65. You will get negative 33 over 65. Okay, so this should be review for those people that took 30 last semester. And it's like a preview for those people that are going to be doing it. Okay, 6.3, double angle identities. Now I contemplated how much detail, yep, did you not have that assignment? Hold on, let me see what I did. Oh, sorry, formula was wrong. That's supposed to be a plus there. Good catch. So change that to a plus. I just gave you guys the formula. This should have been a plus here. I don't know why I wrote minus. No, answer's right. It's good to see someone's paying attention. Okay, so these double angle formulas, if you want to just go through, they're all on your formula sheet, and it's not part of the curriculum to prove these right now. But you can see sine theta plus theta would be, sine 2 theta equals 2 sine theta cos theta. Okay, now these are all on your formula sheet, and they all come from just combining different formulas together and just manipulating them. Okay, and this one is cos 2 theta also, or sorry, not also, but equals cos squared theta minus sine squared theta. Okay, and you can just write on formula sheet. Okay, another one you need to know because cos 2 theta can also equal 2 cos theta, or 2 cos squared theta minus 1. Okay, and remember that when you write cos squared theta, that's the same thing as this. Okay, and if you use the Pythagorean identity again, cos 2 theta also equals 1 minus 2 sine squared theta. Okay, and tan 2 theta equals 2 tan theta over 1 minus tan squared theta. Okay, so more importantly is how do you use these things and what kind of questions can be asked. So it says express as a double angle, right? So if you're looking on your formula sheet, all the double angles there, cos 2x, there's the 3 of them, and then sine 2x just has the one formula, and tan 2x has just the one. So sine 8x, they want that written as a double angle. Well, I can write that as sine 2 times 4x. Okay, now if you look on your sine x, it's 2 sine x cos x. So that would be 2 sine, well, what is x? It is 4x, cos 4x. So this just gets put down below. Now how would you write 13 as a double? Well, that would just be cos 2 times 13 over 2x. Okay, now there's 3 formulas we can write. I guess just for the fun of it, we can do them all. So that would be cos squared 13x over 2 minus sine squared 13x over 2. Or, there's the other one where we could go 2 cos squared 13x over 2 minus 1. Or 1 minus 2, or 1 minus 2 sine squared 13x over 2. Well, because I needed to make this a double, right? Because cos 2a is the form, and how can I make 2a? Like, what can I make a so I don't change the question, but it's cos 2a, right? So if you just had cos 5, right, 5x, make that cos 2 times 5x over 2. And now you've got it in this form, and wherever you see an a, you just put in 5x over 2. Okay, or else you can't use any of these because these only work for double angles. Okay, and tan 20x would be tan 2 times 10x. Again, so always double check, yeah, that equals 20x, and now I can use my formula because this number is going to get substituted in, 2 tan, and x is 10x over 1 minus tan squared 10x. Okay, so these are going back the other way. So if you look on your formula sheet, which one does this kind of look like? cos 2x. Okay, so what are we calling x? So cos 2 3x, which equals cos 6x. Okay, how about b? Okay, so this looks like tan 2x, right? So 2, and x is pi over 8. So that would be tan pi over 4. Okay, this one's a bit more challenging. 1/3 sine, yep. Okay. Yeah, oh yeah, sorry, we can do that one because that's pi over 4 is 1. Yeah, that's good. Yeah, if you can solve them, solve them. We've got 3 people paying attention today. I like this. It's like probably a record. Okay, C. You can kind of see what that one sort of looks like. But how are we going to make it be? It's like sine 2x. How am I going to make it? That seemed to be the strategy of your last test you wrote. Okay, any guesses? Because this is the one, right, so we need to make this thing equal 1/3, right? So we want to go 2 times what? Because I got 2 sine, yeah. So if you did this, okay, now this would be the same thing as 1/6 2 sine theta cos theta, right? And we know 2 sine theta cos theta is sine 2 theta. Yep. Well, I needed this. Oh, how did I just switch them? Because when you have these two multiplying, you can just, like if it was 3 times 2, whatever, I can make that 2 times 3. Well, because I wanted to actually show you this, right? That it's 1/3. Because I need this to equal 1/3. I can't change the question, but I need to get a 2 in there. So some people are saying, why didn't you just go right to this, right? And you could, right? Okay, so one more question. Sine 22.5 degrees. I need exact value. So now, anything come to mind that we know on the unit circle? Times it by 2. What would we multiply by 2? Okay, so this is where we're going to use our, and if you look at it, this is our half angle identities, because sine, I can do surprises in notes, not in tests, I said. Because I can do this, because I know what 45 is in the unit circle. And this equals plus or minus root 1 minus cos 45 all over 2. Okay, and then again, if you draw your unit circle, I got root 2 over 2, root 2 over 2. So I'm taking cos. So this is plus or minus 1 minus root 2 over 2 all over 2. Plus or minus. Now, this is the same thing as root 2 over 2 minus, oops, sorry, 2 over 2 minus root 2 over 2 all over 2, which equals plus or minus, that would be 2 minus root 2 all over 2. Okay, so this is the same thing as times 1/2. You can take this 2 and times by 1/2. So you would get plus or minus 2 minus root 2 all over 4. Okay, now the thing you always have to decide is the sign. Okay, I can't do much more with that. I mean, I guess I could write that as plus or minus square root 2 minus root 2 all over 2 if you really wanted to. But now would that be a plus or a minus though? Plus, because I am in. So it's plus because it's in quadrant 1. Oops, I was doing, yeah. Okay. So for 30, this is pretty well all reviewed.